Hi, today let us see the trees, more specifically binary trees. First of all, we need to know how these binary trees are arranged. Like, trees will have a root node, parent node, and child node. These things will be there. Imagine, for if you don't know how the tree's normal structure looks like, let me show you that. Imagine this is a tree, right? I am writing the tree. So more specifically, I am writing binary tree. Binary tree means every uh, parent node. If it is a parent node, then it should have a two child, right? If it is not a parent node, then it should have no child at all. Like a normal tree looks like this. It is not a binary tree. Now I am drawing normal tree. So this is called the root node. This is a root node. So it has three child, right? 1, 2, 3, right? This node and this node and this node are children of this root node, right? This is also a parent for these three node. You can tell like that. Then this node has a single parent, single child, right? It has a single child. Then this node has a two child, right? So this node will be having two child. So this is like normal structure of tree. It is not a binary tree, right? This is how normal structure we have. So and these two nodes, this one and this one, can be called as siblings, right? Because they are the children of same parent. So this is how normally tree looks like. But binary tree will have a condition, that is, if it is a parent node, right? If this is a parent, if you imagine, it should have a two child. That's it. It should not have single child. It should not have a three child. If it should have a two child. Then if it is a leaf node, again, if you don't know leaf nodes are the nodes which comes at the bottom level of the tree. Means they don't have any child of their own. They're like the like the recent generation, you can take, like you can consider like that. This node is a so much older generation, like a very previous generation, you can consider. So this is how normal tree looks like. Let me draw how binary tree looks like. More specifically, binary tree will have a like if it is a root node. So if imagine it has a child. So if it has a child, then it should have only two child. No, you can't have a three or one child. So again, if this is a node, if it is a parent, if it has a child, then it should have always two child. And again, if it is a child, if it is a parent, it should have a two child. So this is how it works. Again, if this imagine this node will, it is a parent, means it should have a child. It should have a child, that is only two child it should have. Imagine this, no, this node don't have any child. So that can be that can work, right? We can't have always two child. If we consider that condition, then we should draw infinite length of infinite levels of tree. So it should not happen. It should have two or zero child. So this is how condition works. This is how binary tree looks like. So now let us draw how other condition of the binary tree, right? That makes it so much important for us, and I will tell you what is the useful of that. Imagine I'm sending a element like 10. Okay, I'm sending 10. Then next time I'm sending an element that is 5. So what you should do is you should compare 5 with this root node, like the node. Then if this root node is greater than the element, that is, if imagine I'm sending 5, right? As I already said, if 5 is less than 10, then make 5 as its left child, right? Make 5 as its left child. Imagine next time sending another element, like I'm sending 20. Then you check with this 10 whether 20 is less than 10. No, it is greater than 10. So make it as a right child of the 10. So that is how it works. Next time I'm sending 2. Imagine I want to send 2. First of all, you come to this node, root node. Okay, 2 is less than 10, right? Go to left child. Okay, we have 5. Whether 2 is less than 5? Yes. Again, go to left. So when you go to left, it is null, means there is nothing. So you add the 2 here, right? I think it is so much clear. So that is how it works. And like you can add you can go and add as many children as you can. Now what is the use of it? It is used for searching the element, right? The time complexity to search the element in tree will be less than time complexity in searching element in array. So that is where it becomes useful. Like you see, you go if you want to if you have a question like search whether 2 is there or not, then you will go here 10. Okay, after that, since 2 is less than 5, you go here. Since 2 is less than 10, you go to left side of 10. Then there is 5. Since 2 is less than 5, so you go to the left side, so you will get the 2. So you can return this 2 now. This is how binary trees can be helpful. Now let us see how to create this binary tree, right? The creation is so much important and it is so much easy. Like as I said, this process will continue. I will show you that through coding. So let us go to code blocks. I am doing in C++. Int main. Okay, now our objective is this. My objective is I will ask the user how many nodes you need to add. Okay, right? It is n. I will ask the user how many nodes do you need to add. Then he will give me some number like 5 or 6, like this number he will give. Then I will go to the for loop. Int I is equal to 0, I less than n, I plus plus. After that, first of all, let me create a structure. Before that, I should have created that one struct node, because I am using linked list in order to create this binary tree. I am not using array. Then it should have a data. Normally it should have a data. If there is a node, I am talking about, like I am talking about this node, what it should have? It should have a data, like 2 it should have. Then what it should have? It should have a left child and right child. So that is what the condition is. So what I take is left child, that is of the node type, that is L child, HILD child, and again pointer to the node type. So R child, CHILD child. Okay, now I am going to take imagine, let me ask the user what are the elements that he needs to pass. It is X. Then I will ask for scene that X. Okay. After that, see, first of all, the most important thing about tree is you will have access to this root node. Like I already discussed that if this is a like imagine this is a tree, binary tree. So you will have access to root node. Which is the root node? Root node is the first node that you are going to create. That is the root node. You will have access only to this node. Similar to linked list, that you will have access to the first node, right? As we discussed. So similarly, you will have access to root node, right? So initially that is null. Let me make it as null. So let me declare it as a global pointer to the node type. Then I will give it as a root and I will make it as a null. I will tell you why I have made it null. After that, I will make root is equal to insert, insert, insert. What you need to do is insert means creation. You need to insert element, right? Insert. This is a function that is defined by me. Then I will send root node. Then obviously I should send the element. Then I will go here. Then what should I need to return? that is root. So it is a node pointer, right? Node pointer, as I already said, it is a node pointer. So I will return node pointer. Then insert, insert, insert. Then I will take a node, like let me take it as p. Okay. Then key means the element that I need to add. Okay. Now every time, like let me explain how it works. Now imagine I need to create a initially root will be what? It will be null, right? It will be null. Okay, I will delete this one. Okay, initially root will be null. Okay, if it is null, what I need to do is I should create a node. And I should put the data inside it, and I should make its left and right as null. That is what my condition. That is what my objective is. After that, imagine I have added. Let us do that one first, right? I will create a node for that. So node, it is a pointer t. Let me take it as if this p. Actually, I can let me explain you this. This is actually a base case I'm talking about, and I will explain you through creating a recursion tree also. If p, if it is null, means I can give like this, right? If it is null, then what you do is, you have already created a t node, that is of node type t pointer. Then what I do is I will create a new node. Okay, it should have three things. It should have data, it should have left child, it should have right child. I know the data. Data is nothing but the key that is we are talking about. Then t left child will be equal to t right child. As I said, you should make it as a null, right? You should make it as a null. Then what you do is you should return me the node. Okay, this is a base case. Let me go forward and explain you. Let me write the code first. After that, it will be easier for us to learn. So imagine if key is less than p data, then what you need to do is simple. Means if what the key that you are trying to add, right? If you are trying to add, if it is less than, like imagine I already took it 5. Now the key I need to add is 5. Sorry, the root node is 10. I need to add 5. So if 5 is less than 10, then you go to left child, right? You go to left child and get the data, get the value. So let me write the code here. P left L child should be equal to insert, insert. After that, I will pass left child. Then I will pass key. It is so much easy. Let me explain you again. Like p left means I need an element at this p left position. Okay, because 5 is less than 10, right? For that I need to insert. So I will call the function again. So but this time I am passing p left. So p left will instead of p will be not root now. It will be root left, more specifically, and it will come here. Root left is what? It is null. See, it is not yet created, right? At that time, again this if loop will be run. So this will act as a base condition, base case. So it will be executed every time a new node has to be created. So okay, again I have another issue here. Else if let me take it as else if key, what if it becomes greater than p data? Okay, if it is greater than p data, p right, you do whatever you did for p left, you do it for p right also. So insert again p r child, then and key you need to add. Okay, now again let me explain how it works. This now I need to add 20. I have already added 5 here. I need to add 20. For that, what you need to do, I will be sending 10, right? After that, it will see whether 20 is greater than 10. Yeah, it is greater than 10. Then what it, so key is greater than 10. So again, P right I am taking in the code, means P right should be equal to, P right means what? P right means this one. P right should be equal to, insert P right comma key. P right, it will go here. Again P right will go at this position. Again it is null because it is not yet created, so it is null. So again this will be created and it will be returned at this position. So it will be returned 20 at this position. This is how it works. So after that, this will continue, right? Then at last, what I need to do is I should return P for every time. Every time I should return P, right? Because see, this P the next see, I will again explain you this one. See, every time I should return a node type. That is what my function is doing. What it should return? It should return the root node, because see, I am asking here root. So root I should get a root here. So let me explain for the next iteration, for next level. Let me explain. It will be completely clear, I think. Okay, I will copy this code here and I will paste this here. Okay, I'll make it somewhat big. I'll make it to 36. No, 24. Okay, it is clear. Now, imagine I need to add, right? I am sending a from root node, from int main. I am sending the element, right? Now, I need to add 2. At this time, this function will be, it will come to this function. Obviously, I am calling this function, it should come here. What you are sending? You are sending root itself. Means you are sending this 10th position, because you have only access to that 10th position. As I said, you have access. See, I am sending root here, right? So you have access to that 10th position. That's it. So I am sending what I have the access to. So I am sending 10. Imagine the 10th position I am sending it. So I am creating a new node. Okay, if it is equal to none, whether it is equal to none, no, it is not equal to none. Actually, this code can be written, if you are getting confused, this is nothing but if it is equal to null, that is what this code tells. If it is null, right? 10, whether it is null, no, it is not null. So you don't execute this if statement. Then go here. Whether key is less than P data. Here P means what? P means what? Right? P means root here. So root is 10. Whether key is what here? Key, let me write here, key I am sending is 2. Okay, I am sending 2. 2 is less than 10. Yeah, definitely it is less than 10. Then you call this function. But at this time, P left means what here? P is at root. It is P left means 5. 5 is equal to whether this position is equal, that should be inserted with P left comma key. Means again here I am passing P left means 5. I am again calling this function 5 comma 2, right? Again previously I had 10 comma 2. So this same thing, now I have 5 comma 2. Again this will come here. So it will, this if statement don't work, again it is not null. Then again it will go to this if statement. Then here 2 is less than 5. Yes. Then P left. Then what should I do for P left? You need to insert. What you need to insert? P left comma key you send. Right? P left. Again P left means null you are sending here. P is 5 at this point. So P left means again this is null. If there is nothing there here means it is null. So you are passing null here. Okay, you are passing null. So at that time when you are coming to this statement, you at this point this if statement will be accepted. This will be true. So because it is null, P is null. Okay. Now you create a new node. Okay, I am going to create. At which position? See, you can observe P left. At P left position, whatever you need to do, you can create. Okay, at this P left, you create a new node. So, okay, I created a new node. P data, T data should be key. Okay, you need to add that data, which is at 2. Okay, I am adding. P left, P right should be null. Okay, I am not adding anything here. It is null. Then return T. You should return me T. At this P left, you return T. Means I am returning here a 2 node. So now it is completely connected after returning. Okay. After that, this statement is over and it will be not executed. Then return P. So it is so much important. Why return P? See, you need to come back, right? You need to come back to this position, right? Return P will, what it makes is, it will make sure you go back to this previous recursion. You need to go back to this previous value, right? For that reason, you can use P, right? Here, why it is not returning to the main function? If you have that doubt, you should look here that I am recursion. See, recursion, how it works means, it will come through the recursion tree, right? It will come down like creating a tree. After that, it will not go directly to the upper node, like top node. What it does is, it will gradually moves up. It will go next step. After that, it will go to the next step. Here the P return P, what I am doing is, I am going to the previous step. I am not returning the P value to the int main. Don't think like that. I am returning 2 to the 2 as a root to the int main function. It is not like that. It will return back. Like, okay, it will return back again. Again, what happens is, again it should return back. See, if it is if it returns back, then I will be in this position, right? I'll be in this position. So again, this will be turned false. Again, now my value is what, right? This will be turning false again, and after that, you want to return again P, means again it will go back here. So just imagine, like how you have come through the tree, right? Like that only you can go, like single step at a time. So when you are returning something, imagine this will not go directly to the main function. It will be returning, and through tree it will go up. It will be clear if you work out. So after that, you go to the root node. After that, you need to return, because there is no other function call. You return that one. So like this it will work. And when after that, you can give other elements and you can check. Like I am going to give 7. Right now at this time, I am sending a new element for this. So there will be no difference here. Instead of working this, so initially this condition will be working like 7. Okay, I am sending 7 here. Sorry, it is root node. Okay, key value is what, 7. Okay, this root is equal to null. No, it is 10. It is not equal to null. Okay, then again, if this will be failed, again it will come here. Whether key is equal to is less than P data, that is 7 is equal to 10. 7 is less than 10. Yes, 7 is less than 10. Then you execute this one. Means you should go to 5. Now it's a time to go to P left. Here P is 10, P left is 5. So it is a time to go to P left again. After that, you should what you need to do again. It will be calling right. This will be calling right again. Actually, you know what? It will come here. After that, P left is equal to insert P left comma key. That means if key is less than P data, right? If 7 is less than 10, you do this one. While doing what you are sending here, P left. That means you are sending 5 itself. Okay, you are calling again function. You come here. So this will be not executed. After that, this will be not executed because key is 7. P data is 5 because I am at this position. So this will not work. Again, this will work. So key is what? 7, key is key is greater than 5, right? So this will work, and p right we are calling. So p right we are calling, it is null. Actually initially it is null. I am just drawn this, but initially it is null. So you go again to the function call, then come here. So it is null. So execute this, create a node, return 7 at this position. Okay. After that, you make it as null. Then you have to return. Yeah, that is normally that works. Then again, this is over. This is what return to this function, right? For this, it is return. Here, this imagine this as a local function call. Locally, it is calling. It is not related to any other the main call. So what it want is p right should be 7. So it has created, it has achieved its objective. After this, it will go to the next line. P return p. Actually, we are still at the recursion level, like down the recursion tree. We are not at the top. Like it should go to top, right? As I said, it will be return 7. Means I am going here. After that, I will go here again. After again, return p will be executed. After that, p is root. Then it will be return, right? That will be written. So root will be written at all time. So let me code this. So we need to display, that is so again display can be made of many things you can display, many like pre-order, in order, post order. That is what you can do. Like imagine I will show you how it works. So let me clear this one. Okay, so pre-order, post order, they are so much important when you are displaying, because see, this is a root node, right? This is a root node. Again 10 I am going to take. Then again this is 5. This is 20. Then again this is 2. Again this is 2. Again this is 7. Again this is 15. Let us take 15. Again this let me take it as 25, right? Pre-order means what you need to do is you just draw a line at the left side. Okay, you need to draw left side. Left side. You need to draw this line. Okay, after that, start from here. Traverse to like simply go on touching these lines. So you need to go like this. You need to touch here. You need to touch here. So you keep on touching and come back to the initial position, right? Okay, now first thing what you touched was 10, so 10. Second thing what you touched was 5, then 2. Then you went here, again 7 you are touching, again you are 20 you are touching, again here 15 you are touching, again 25 you are touching. So this is a pre-order. So let me draw the post order for this, right? Let me clear this one. Post order will be somewhat similar, but imagine we have again same thing here. Instead of like drawing some as I draw some line, right? Instead of that, let me take same example. So what I gave was, I think 5 here, 20 here, I think 2, okay, 2, 7, then 15, okay, 25. This time, this is pre-order, right? This is pre-order. Let me show in order. Draw a line here, down, right? You draw a line. After that, you should keep on touching everything, right? So again, start from here. You go, nothing here there to touch. Okay, this is what you touch first. Then again touch it, touch. Then again you should go like this itself. You should always go like this. The line may vary. Line may goes to different position based on the different display, like different way of displaying this tree. So first thing you touched was 2. Okay, 2. Next thing you touched was this one, 5. Next thing was 7. Next thing was 10. Next thing was 15. Next thing was 20. Next thing was 25. So the post this is what in order. In post order, what you do is you should write the line here. After that, let me show you that one. So I will simply remove this one. Okay, now 10, the elements are 10, 5, this is 20, this is 2, this is 7, this is 15, this is 25. You draw a line here. Okay, after drawing, you can you should always start here. As I said, you touch this one first, after that you touch this one, then after that you touch this one, then this one and this one. And let me draw it again. You have, this is the first thing you touched. Okay, next you have touched this thing. Okay, next this one, next one, this one you touch, then you touch this one, then you have touched this one, then this one. So if I write the post order will be like this. First thing you touched was 2, okay, 2, then 5 you did not touch, 7 you touched, okay, then you have touched 5, okay, 5, then you have touched 15, okay, 15, then you have touched 25, then here you went and touched 20, okay, 20, then at last you have touched 10, right, 10. So if I give the same at the in coding section, if I give the same input, I should get this pre-order, post-order like this. So let me write a how to in this session, let us discuss only about pre-order, right? Pre-order, if you know about pre-order, other two will be easy. Let me write a code for that. It should return nothing, so it is pre-order, so I will take it as pre-order. Then node, I will, because I will always send a root node, right? I will send root node here. After sending root node, I will do recursion. If this p is not equal to null, if it is not equal to null, then what you do is you get into this function. Then what you do is you should print I will explain this recursion afterwards. Pre-order, then p left, I am calling left child, right? Then again pre-order, right child I am calling, right? This is how it works. Let me call this function afterwards, that is pre-order. The root I am sending, right? As I said, I am sending root, so it should be printed. So let me run, let us see any mistakes. Okay, there is some pre-order was not declared in the scope. So this is a pre-order, it is a function pre-order void node. I think there is this one problem here. So it is running fine. So I am going to give like 7, same thing what I did here. It is 1 2 3 4 5 6 7 values I am going to give, right? 7 values I am giving, 7. After that I will give 10, then 5, 20, then 2, 7, 15, then 25. So okay, I am printing like this. Let me see. Okay, 10, 5, 2, 7, 20, 15, 25. So this is how we have achieved our objective by displaying and creating the root node. In the next video, I am going to explain you how this recursion of the pre-order, in order and post order will work, because this video is going to be lengthy, I think. So thank you.